So we're given 4 coordinates, A, B, C, D, okay, in the question, and because they are sort of low value coordinates, I've done a grid here, Cartesian grid, where I've actually done it to scale. So I've measured every centimetre to represent 1. Okay, so I plotted the points then accurately. And then in part A, to show that A, B and C, D are parallel. So, you know, because I've done this accurately, you can see they look parallel. It kind of helps you to visualize what's going on here. So to show they parallel, remember, we need to use this formula here, to look at what the gradient is for each of them. So if I consider, for instance, to start with an AB, so A is 1, 7, and B is 5 minus 1. Okay, now it doesn't matter what you call your first coordinate. You could call this your first coordinate if you want, x1, y1, and that's your second coordinate, x2, y2. So to work out the gradient then for AB, you just use this formula. Okay, so remember then on the top then is y2 minus y1, the difference in y's. So it'll be minus 1 for y2 and minus, then take away then the y1 which is 7. All over then x2 which is 5, take away x1 which is 1. Okay, so if I work that out, okay, on my calculator, I will get minus 2. Okay, so I'll do the same then for the CD. Okay, so CD, well, the point C is 8, 3, and the point D is 6, 7. Okay, so if I then call this my x1, y1, and then that my x2, y2, so the gradient then of CD, well, you've got y2 which is 7, take away y1 which is 3, all over then x2 which is 6, take away then x1 which is 8. So if I work that out there, okay, again, you know, check that on your calculator, you get again minus 2. Okay, so because the gradients are equal, they're of the same value, gradients tells us the slope of the curve of the line joining them. So we could say, look, since the gradient AB is equal to gradient CD, AB is indeed parallel, okay, to CD. Okay, so we're sorted that. Now in part B then, the next part, it says find the equation of AB, yeah? So the equation of AB. Now remember, to get the equation, you need the gradient and you need a point on that line, right? So we know the gradient of AB is equal to minus 2, and we need a point, don't we? So the point we can choose, well, you can choose any point. You can choose B or you can choose A. I'm going to choose the point A because it's positive, isn't it? So for the equation formula then, okay, there's two ways of writing it out. So you could do what, so that, you know, y minus y1 equals m, then x minus x1. Okay, so that's the general equation for the line, or sometimes you'll see it written so that the x minus x1 is divided here, and it'll equal to m. But that's the one we can learn there. Okay, so you just put your point in. So your y1 is 7. Your m, your gradient is minus 2, and then your x1 then is 1. So there you go. Just tidy this up a little bit, simplify it. So we multiply out that bracket there, so you get minus 2x and then plus 2, okay, when you expand that bracket. And maybe get everything to the left hand side. So you'll have 2x, if I bring that minus 2x over, it becomes plus 2x, plus y then, and then you've got minus 7, and then take that 2 over, it becomes minus 2, so you get minus 9 overall. So there's your equation for AB. Okay, so then part C, it says the line L passes through, let's have a look at it, the line L passes through the point D and is perpendicular to AB. Show that L has this equation. So if we to draw this, if the line L passes through the point D, okay, like that, but it's actually perpendicular to AB. So in other words, it's at a right angle. So that's how you see that there, right? Perpendicular means right angle to AB, okay, and it passes through D. So we want to show that the equation for L is this here. So a couple of things. First of all, we know it goes through point D, our line L here, okay. So we've got a point, haven't we? We use that point D, which is 6, 7. We also need the gradient as well. Okay, so the gradient of the line. Now, because of course it's perpendicular to AB, we can use the formula for perpendicular properties. Okay, m1, m2 is minus 1. And we know the gradient of AB, the one that's perpendicular to it, is minus 2. Okay, so we can put minus 2 for the line that's perpendicular to it, and then we can get the gradient then for the line we want, for line L. So if we take that minus 2 over, we get that, so we get a half. So gradient is a half. So the equation will be y, again, minus y1 is mx minus x1. Okay, so y minus, well, the y1 is 7, gradient is half, and the x value there is 6. Okay, so what I do here is when you've got a fraction here, I would take that bottom number over. So, and of course when you take it over, you're gonna, the 2 over, you're gonna multiply all of this. Okay, so put it in the bracket, and then you just got 1 then, and your x minus 6, so you get 2y minus 14 equals x minus 6, and then get it onto one side like they've got, so x minus 2y, and then you get plus 8 equals 0, which is exactly what they've got.